Hello. In this lecture, we shall dive a little deeper into data representations in natural language processing and the more recent advancements in this field. There are different levels of tasks in natural language processing, from speech processing to semantic interpretation of discourse processing. The overall goal of natural language processing is to be able to design algorithms to allow computers to understand natural language in order to perform some tasks. Now, these tasks can come in varying levels of difficulty. For example, easy tasks like finding synonyms, checking spellings, and keyword matching are relatively simple for computers to accomplish. And this is because of fewer explicit rules therein. On the other hand, translating arbitrary pieces of text into different languages or answering complex questions which require real world knowledge and reasoning abilities are considered to be hard tasks. Apart from easy and hard tasks, there are also tasks with medium difficulty, like parsing text web pages to extract text from other content like pictures and images. These tasks were traditionally considered as difficult, but now are considered as easy. Now we come to an important aspect of natural language processing, which is to represent the smallest unit of language, which are words. Most modern natural language systems now rely on data-driven statistical models to solve natural language tasks. Now, these models traditionally are frequency-based statistical models, and more recently are neural network-based models. The first and arguably the most important design decisions across all of these tasks is how do we represent words as input into our models that understand language. In representing words as input to any of our statistical models, we first need to have some notion of similarity and differences between words to perform well on most of the NLP tasks. One natural way of representing words so that computers understand is by using vectors. Representing words as vectors have certain advantages. Firstly, if you use vectors to represent words, then the notion of similarity can be encoded by the distance between vectors in the vector space. This is a natural and intuitive geometric interpretation for both humans and machines. Specifically for computers or machines, vectors are mathematical objects that can be manipulated easily using linear algebra or machine learning techniques. Another advantage of using vector representations is that it is composable to represent longer pieces of documents or passages. For example, a simple model that is called the bag of words model for documents can simply be the sum or average of the word vectors that contained in it. Let us look at the simplest vector space representation of words. We first start by defining a vocabulary of all possible tokens or words. Note that a token might be a word in the dictionary, but it could also be a string of Unicode characters used in common language, for example, emojis or hashtags. The vocabulary that is used here is very large. That is, it can easily be in the orders of tens of millions of tokens for one hot representations or simple representations. In a one hot representation, each dimension corresponds to a token in the vocabulary. We will represent every word as one vector with all zeros, but with exactly one single one at the index of that word in the vector. In this notation, the number of dimensions is in fact the size of the vocabulary. Word vectors in this kind or type of encoding would appear as the following. You can see that for the vector of the word, you have 1 at the position of the dimension corresponding to the word, and rest all the values are 0. Note that each word is considered independent of every other word. Now, what does this mean? This means that the dot product of any pair of vectors from the entire vocabulary will give you a value of 0.